Section 1, trig identities. We have reciprocal and quotient identities. The reciprocal identities we pretty much know already. We've talked about these. The inverse, not inverse, but the reciprocal of sine is cosecant. Cosecant is a reciprocal of cosecant, and you can go the other way around. The reciprocal of cosecant is sine, and the reciprocal of secant is cosine. We also know that the reciprocal of tangent is cotangent, and the reciprocal of cotangent is tangent. Now, tangent is also the same as sine over cosine, and cotangent is the same as cosine over sine. Now, in letter A, we can find the value of sine just by using the properties. We have the secant of x is 5/4, tangent of x is 3/4. If secant of x is 5/4, then cosine of x is equal to 4/5. And tangent of x is equal to sine of x over cosine of x. Now they tell us that tangent is 3/4. We're trying to find sine of x, and we know that cosine is 4/5. So we can replace this cosine with 4/5. Now to solve for sine of x, we can multiply both sides by 4/5. The 4's will cancel, and the sine of x is equal to 3/5. With letter B, we have secant of theta is equal to 13/5, and the sine, they want us to find sine. Cosine of theta is equal to 5/13, and we don't quite have enough information to just use the properties. We have to use a triangle for this. So if this is the angle, then cosine is 5/13, and we need the other side. So we have 169 minus 25, that's 144. So the other side is 12. So now the sine of whatever this angle is 12/13. So we can't get away from using a triangle on this one. Pythagorean identities. The Pythagorean identities are, first, one of them is sine squared plus cosine squared equals 1. Now, where does that come from? If you have a circle, pick any point on the unit circle where this radius is 1. If you take the x squared plus the y squared, that's going to always be equal to 1 because that's the unit circle and the radius is 1. So we get this Pythagorean identity. Now, if we take that Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and let's say we want to get tangent, we can divide everybody by cosine squared, because sine squared over cosine squared is tangent. So we're dividing everybody by cosine squared. So cosine squared theta. This right here, this becomes tangent. So here's your tangent squared theta. There's tangent squared theta right there. And then plus cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So that's where we get the second Pythagorean identity. If you take the original one now, instead of dividing by cosine, we divide by sine, then you'll have cotangent squared plus 1 equals cosecant squared. As a matter of fact, if you divide this by sine squared, you actually get the 1 first, but it's addition, so it doesn't matter what order it's in. A, if cotangent theta equals 2 and cosine is negative or less than 0, find sine and cosine. Well, cotangent squared plus 1 is equal to cosecant squared theta. So we have 2 squared, which is 4 plus 1, is cosecant squared theta. And then we have cosecant squared theta is equal to 5. So cosecant of theta is equal to plus or minus the square root of 5. Now this, now we have the sine of theta is equal to plus or minus 1 over square root of 5. But if cotangent is positive and cosine is negative, then sine must be negative also. So the sine of theta is equal to negative 1 over square root of 5. And we are asked to find cosine as well. Sine squared plus cosine squared is equal to 1. And sine squared is 1 over 5 plus cosine squared theta equals 1. We have cosine squared theta is equal to 5/5 minus 1/5 is 4/5. Cosine now is equal to, it would be plus or minus, but they're telling us that cosine is negative. It's negative 2 over square root of 5. Letter B, find the value of cosecant theta and cotangent theta if tangent of theta is equal to negative 4/3 and cosine is negative. Well, if tangent is negative and cosine is negative, then sine of theta must be positive in order for sine over cosine to be negative. They've told us what tangent is, so cotangent of theta is pretty much given. It's negative 3/4. It's the reciprocal of tangent. We want cosecant of theta, and cosecant theta is involved with, right here, this Pythagorean identity. So if we use cotangent, add 1, we have cosecant squared. So cotangent squared, that would be 9/16 plus 1 is equal to cosecant squared theta. 9/16 plus 16/16, that's 1, is 25/16. Now that's cosecant squared theta. So cosecant squared theta is equal to, cosecant theta is equal to plus or minus 5/4. Now we have to choose whether that's a positive or a negative. Cosecant is the reciprocal of sine, and if sine is positive, then cosecant must be positive. So cosecant theta is equal to positive 5/4. Odd and even identities. Sine of opposite of theta is equal to opposite sine of theta. So sine is an odd function and cosecant is an odd function. Here's what we usually write with odd functions. Now think of the graph of sine. Starts at 0, goes to 1, back to 0, and it does this. And then on the other side, it goes down and then back up. Well, if you pick any point on sine, go through the origin, you should find its corresponding point. So sine is an odd function. It is reflected over the origin. An even function says if f of negative x, or f of negative x equals f of x, like cosine and secant. Cosine starts up at 1 and then goes down in this manner. And then on the other side, it goes down in this manner as well. Well, if you pick a point on the left side of the y-axis, the corresponding point should be on the other side of the y-axis. Even functions are reflections over the y-axis, just like cosine. And then there's tangent and cotangent. Here is tangent right here, and it is a reflection over the origin. So that is an odd function. We can say that f of negative x equals negative f of x. In other words, tangent of negative theta is the same as writing negative tangent of theta. You'll get the same value. We also have cofunction identities. The sine of theta is equal to the cosine of pi over 2 minus theta, and so on. So we have cosine of theta is the same as the sine of pi over 2 minus theta. Same with tangent and cotangent, same with cotangent and tangent. Secant and cosecant have the exact same relationship. So on all these, you can get its other function by doing pi over 2 minus theta. So if we have this. If cosine of theta is negative 0.75, find sine of x minus pi over 2. Well, we don't want sine of x minus pi over 2. We want sine of pi over 2 minus x. I mean, that's what this says right here. I'd love to have that statement right there. Then it would be the exact same as cosine of theta. So how are we going to get this to say this right here? Well, we can factor out a negative 1 inside. So we can write that this right here is equal to the sine of negative 1 times, if I factor out a negative 1, that negative pi over 2 becomes positive pi over 2, and the x becomes negative x. So I have minus x. Well, sine is an odd function. So if we go back to the odd and the even, the sine of negative theta is equal to the negative sine of theta because they're odd. So I can take this negative that's on the inside and I can move it to the outside. So then I'll have pi over 2 minus x, and that's exactly what we wanted. We wanted sine of pi over 2 minus x, or minus theta. And we can change this piece right here to cosine of x. Well, now the cosine of x is equal to negative 0.75, and the opposite of that is 0.75. So the answer is 0.75. Now what it comes down to, now that seemed like I was jumping all over the place, but really all we did was we factored out a negative 1 out of the inside of that, and because sine is odd, that negative can bounce out front. Then we replace this with cosine and then use the value. So mainly we just factored a negative 1 out and used the properties. Simplify 1 over cosine times 1 minus sine squared. The Pythagorean identity says that that is equal to cosine squared. We have sine squared theta, or x, let's use x's since we're using x's, plus cosine squared x is equal to 1. Well, if we minus this sine squared over, we get cosine squared x equals 1 minus sine squared x. So 1 minus sine squared x can be replaced with cosine squared. We have 1 over cosine x times cosine squared x. Well, one of the cosines will cancel, and the answer is cosine x. That's this expression simplified. Over on this one, let's turn everything into sines and cosines. Cosecant is 1 over sine of x. We'll leave cosine x alone. And then cotangent is cosine of x over sine of x. Well, cosine times cosine is cosine squared. We have minus cosine squared x over sine of x. That's common denominator. 1 minus cosine squared x over sine of x. And then just like cosine squared is equal to 1 minus sine squared, we can say 1 minus cosine squared is equal to sine squared. So we have sine squared over sine of x. One of the signs cancels out, and the answer is just sine x. Simplify cosine x tangent of x minus sine x cosine squared x. Let's try to turn all of this into sines and cosines. In other words, we're going to turn tangent into sine and cosine. We have cosine of x times sine of x over cosine of x minus sine of x cosine squared of x. Well, these cosines cancel out, leaving sine of x minus sine of x cosine squared x. Now we can factor out a sine x, 1 minus cosine squared x, and 1 minus cosine squared x is the same as sine squared. We have sine of x times sine squared of x, which is sine to the third of x. Simplify cosine squared sine minus cosine of 90 degrees minus x. We have cosine squared of x times the sine of x minus, if we go back a few slides, we have the cofunction identities, which says, I think we had sine of 90 minus theta is the same as cosine of theta. We can change this part, the cosine of 90 minus x, into sine of x. That's the same thing. We can factor out a sine x, cosine squared x minus 1. And then this is sine of x. We can take a negative out of this parentheses and write 1 minus cosine squared x. So we have negative sine of x times, we can change 1 minus cosine squared to sine squared, and we have negative sine to the third of x. Simplify 1 plus cosine x over sine x plus sine of x over 1 plus cosine x. We can use common denominator here to combine the two fractions. Let's multiply this one by 1 plus cosine x over 1 plus cosine x, and we'll multiply the other one by sine of x. And now the denominators are exactly the same. Let's look at the numerators. We have 1 plus cosine of x times 1 plus cosine of x, and then plus sine squared x, because sine times sine will give us sine squared. Now we'll use FOIL. I mean, just because we have cosine here doesn't mean the rules change. We can FOIL these two together. We have 1 plus 2 cosine of x plus cosine squared x plus sine squared x. Cosine squared x plus sine squared x is 1. 1 plus 1 is 2. We have 2 plus 2 cosine x. We can't forget that we have this over the common denominator, which is sine of x times 1 plus cosine of x. On the top, we can factor out a 2. That's 1 plus cosine of x over sine of x times 1 plus cosine of x. Now, because this multiplication is here, we can cancel out all of the 1 plus cosine x. We have 2 over sine of x, and we don't like to leave it as a fraction if we can help it. And in this case, 1 over sine is the same as cosecant of x. So the answer is 2 cosecant x. Rewrite as an expression that does not involve a fraction. 1 plus tangent squared is equal to secant squared. So I can replace the 1 plus tangent squared with secant squared, and it's over cosecant of x. Well, secant squared is the same as 1 over cosine squared, and cosecant squared is the same as 1 over sine squared. Now this is a complex fraction. I can multiply the top and the bottom by sine squared. Those sines cancel, and we're left with sine squared x over cosine squared x. Sine over cosine is tangent, so this is tangent squared x. On the other side, we have sine squared over 1 plus cosine x. There's not much we can do with this. We actually have to introduce something into this. And what we're going to introduce is 1 minus cosine of x. 1 minus cosine of x. And in the denominator, what we really have now, when we combine these two, is the difference of two squares. So one of the techniques you can use is to try to get the difference of two squares. On top, we have sine squared x times 1 minus cosine x. And now in the denominator, we'll have 1 minus cosine squared x. If you FOIL these together, you're going to get negative cosine plus cosine, and those two in the middle cancel each other out. We have sine squared of x times 1 minus cosine of x over 1 minus cosine squared is sine squared of x. The sine squareds cancel, and we're left with 1 minus cosine of